A wooden chute is being built, along which wooden crates of merchandise are to be slid down into the basement of a store. What angle with the horizontal should the chute make if the crates are to slide down at constant speed? With what force must a 100-kilogram crate be pushed in order to start sliding down the chute if the angle of the chute is that found in A? So it's wooden crate on a wooden chute. So that's wood on wood. So the coefficient of static and kinetic friction for wood and wood is, or are these values here. So let's start solving letter A, but let's draw first. What happened here? So let's say that this is the horizontal, and then we have this is our wooden chute, yeah, and then this is our crate. Alright, that's our crate. Now that chute forms an angle theta with the horizontal. Now we are asked in letter A, what angle with the horizontal should the chute make if the crates are to slide down at constant speed? So for letter A, let's draw that again. This is our angle theta. Then what are the forces involved? It is sliding down at constant speed. It's already moving. Meaning, for there is the weight directed downward. Okay, these are the forces involved. And then this is our normal force, right? That's Fn. And then what else? This is our frictional force there, Fk. It's opposing motion. Because it's sliding down, then the frictional force is directed upward. What is that? So that is Fk. So to balance the forces along the chute, what are the forces involved? So the net force, F net, is equal to 0, right? Why is it 0? Because it is sliding down at constant speed. Or we can also make that F net is equal to, but it's the summation, basically the summation of the forces directed there minus the forces directed down. Okay, so directed upward along the plane, that's Fk, minus the forces directed downward. What are these forces? So this is a component of the force. This is Fw sine of theta. So minus Fw sine of theta. Diba? So that's Ma equals mu k Fn minus Fw sine of theta. But again, because the chute is sliding down, the crates are sliding down at constant speed, then this acceleration is 0, which means that mu k Fn equals Fw sine of theta. Okay, before I continue, let's try to find the normal force. So, perpendicular, forces perpendicular to the surface. So, F net is also 0. Okay, perpendicular. So, along this, no, upward force is net force. So, that's Fn. And so, my downward, what's the downward force here? Is this component, no, the horizontal component of Fw. So, that is Fw cosine of theta. So minus Fw cosine of theta. But this net force is 0. There is no movement along that plane. So Fn is equal to Fw cosine of theta. So we can just substitute that. So mu k Fn is Fw cosine of theta equals Fw sine of theta. So cancel Fw, mu k equals sine theta over cosine theta. Sine over cosine is tangent, so tangent theta equals mu k, just like what we solved earlier. So that's arctangent of, it is mu k equal to between wood and wood. Mu k coefficient is, that's 0.2, 0.2. So that is arctangent of 0.2 is equivalent to 11.3099 degrees. So that is the angle, no, that the chute should make with the horizontal to make the crates go down the chute at a constant speed. Now for letter B, the question is, what force must a 100-kilogram crate be pushed in order to start sliding down the chute if the angle of the chute is that found in A? So to start sliding down, what does that mean? Pila dapat ang i-apply nga force to start sliding down, which means we're talking about static friction. So if this is our plane, this is our chute, then this is our crate here, and then the crate is 100 kilograms. It's directed downward, 100 kilograms. So there is a static friction which must be overcome. So pila dapat ang force directed downward. So but this is, if this weight here, the weight downward, no. So let's make that Fw. So we have Fw sine of theta. This is our angle theta here. But there is another force that is applied. No, pila na siya ang applied force to be overcome. And then we have the force perpendicular to the plane, which is Fw cosine theta. And we have the net force directed upward Fn. So along the vertical, let me just transfer this other solution. We'll transfer this here, okay? So F net equals Fn minus Fw cosine of theta. So Fn equals Fw cosine of theta because net force is 0. So let's erase this. So for forces perpendicular to the plane, it is still the same as this one. Let's say, okay, forces perpendicular to chute. So Fn equals F, that's F net equals Fn minus Fw cosine of theta. Or because that's 0, so Fn equals Fw cosine of theta. This is 0. Then forces parallel to the chute. So F net is equal to all the upward forces. That's the static friction. And then all the forces going down is the applied force Fa minus the vertical component of Fw, which is Fw sine theta. Still, the net force is 0. Okay, to start moving pa man. So Fs is equal to Fa, or Fa rather, because we're looking for the applied force, no? With what force must be applied? So Fa equals Fs minus Fw sine of theta. But that static friction is mu s Fn minus Fw sine of theta. But that Fn is Fw cosine of theta. Okay, minus Fw sine of theta. So we can factor out Fw. That's mu s cosine of theta minus sine of theta. But then Fw is the mass of the crate times acceleration due to gravity. Mu s cosine theta minus sine theta. The mass is 100 kilograms times 9.81 meters per second squared. Mu s, what is coefficient of static friction? So it's a range, so let's try the biggest value, 0.5. Cosine of the angle theta earlier, 11.31 degrees, minus sine of 11.31 degrees. So we're writing 11.31 degrees, but you have to make sure na even if we wrote here 11.3099, again, you have to make sure that the angle that you will be using would be the exact, no, not the rounded off value. So 100 times 9.81 times 0.5 of cosine of the angle minus sine of the angle. And so the applied force, the force that must be applied so that the 100 kilogram crate will be pushed in order to start it sliding down, is 288.5849 newtons. So para mo start na og slide ang crate, that is the force that must be applied.